It's time now to solve some trig equations. Now, what we mean by a trig equation is a situation where we have sine of an angle, and we don't know the angle's equal to a ratio, and we have to find out what the angle could be. Now, before we do that, things to remember. Remember our four quadrants, and where sine, tan, and cos are positive and negative. So all are positive in the first, only sine's positive in the second, and remember our related angle is given to us by the 180 minus theta, so that theta is our related angle. For tan, we have in the third quadrant, being positive, and we add our related angle there, so sine and cos are negative. And in the fourth quadrant, we subtract our related angle, and cosine gives us, and we get a cosine being positive there, and tan and sine being negative. So, think about this one. What's the value of sine of 30 degrees? Well, if we go back to our exact values, we think about sine of 30 as our opposite on our adjacent, we would get that being a half. Now, sine of 150 degrees is in the second quadrant, and sine is positive in the second quadrant, so we get that being a half, because sine of 150 is the same as sine of 30, because we can write 150 as the 180 minus theta, so we get the idea that our related angle to sine of 150 is 30, so it's going to be the same because they're in the second, because of the second quadrant, sine's positive. So when we have this situation then, and say, well, sine of what angle would equal a half? Well, what do we write down? Because sine of 30 is a half, and sine of 150 is a half. So we could technically write down, well, both of them are correct, because either of those answers are correct. And why does the equation have two solutions? Because sine's positive in first and second quadrants. Now, we've said two solutions to that. Technically, we could have much more than that. We could have an infinite number of solutions, because 30 degrees, we consider 30 degrees there and do a complete 360 degrees, well, sine of 390 would equal a half. And then add another 362, 150. Or subtract 360 degrees. And we say, well, minus 330 degrees. Sine of minus 330 degrees would equal a half, because it would be in the same spot. So technically, anytime we get an angle that looks like that, or the point on the circle to be at those points, sine of the angles that they create there will give me a half every time. So really, we've got an infinite number of solutions. We don't really want to go to those infinite number of solutions in this course, because that's a bit hard. It's a bit hard to write down. Extension 1 and Extension 2 will deal with that sort of work. But 2, we just really want to limit our domain, really. So what do we need to do? First step, look at the ratio and ignore the sign. So again, we want to get our related angle. So we're looking at cosine of what an angle would equal root 3 on 2. Find our related angle. Don't worry about whether it's positive or negative. Get that related angle every time, because that's one of the two important parts there. The next one is to look at the sign and consider the trig ratio and the sign. It's cosine and it's positive. So what quadrants are we in? We're in the first and the fourth quadrants. And then once we've got what quadrants we're in, and we've got our related angle, we can start to look and say, okay, what is going to be the angle? So in the first quadrant, we're going to have 30 degrees, because that's our related angle anyway. It's going to be the acute angle in the first quadrant. Or if it's in the fourth quadrant, we subtract 30 from 360 degrees, which gives us the 330. Then what do? You go back and check. You go back and check cosine of 30 degrees is equal to root 3 on 2. And you check cosine of 330 degrees is equal to root 3 on 2. So you go back and check your equation. Like we do all other equations, we can find out what if our solution actually works by substituting it in the start again. Now, all the questions we're going to do here, notice we're going to restrict our domain. Theta is always going to be between 0 and 360 degrees. So that's important, because that's telling us that for most situations we're going to have two solutions. So because that's a restriction. One revolution is our restriction here. So what are we looking at? Cosine of theta equal to minus a half. So what's our related angle? Ignore the sine, take inverse cosine of a half, gives us 60 degrees. Now that you can throw that in the calculator and that will work for you. And then consider cosine being negative. It's in the second and third quadrant. So cos, it was negative. We got our second, we got our third quadrant. So how do we get our angles in the second quadrant? We subtract the related angle from 180. That gives us an angle between 90 and 180. And then in the third quadrant, we add the 60 degrees to the 180. So that gives us an angle between 180 and 270. So there's our 2. Substitute it back in. If you put cos of 120 into the calculator, it will give you minus a half. Substitute cos of 240, put 240 in, and that will give you minus a half as well. So that will work every time you put it in the calculator. Tan of theta is equal to minus 1. Again, what's our related angle? Inverse tan of 1 gives us 45 degrees. And where's tan negative? It's tan in the second and the fourth quadrant. So again, we subtract our related angle from 180 and 360 to give us those two solutions. So hopefully you're starting to see the process. Get your related angle. So inverse sine of root 3 on 2 gives us a related angle of 60 degrees. Where's sine positive? The first and the second. So we've got our related angle, so that nothing has to go on there. But we subtract 60 from 180 to give us 120 to give us the angle that's in the second quadrant. This time here, well, we're not going to get us an exact value because sine of theta is equal to 0.35. So put it in the calculator, we'll approximately get 20 degrees. But again, we're sine positive, so our related angle is going to be about 20 degrees, and we're happy to round it to the nearest degree. So in the first quadrant, it's just going to be 20. In the second quadrant, we're going to have 180 minus 20, and that's going to give you 160 degrees. Again, when you sub that back in, it won't give you exact because it's 160. We've taken an approximation of 20. So, but it'll give you something close to 0.35, and that's good enough for what we need. Tan theta is equal to minus 1 on root 3. Well, what's our related angle? Inverse tan of 1 on root 3 is 30 degrees. And tan negative means we got the second and fourth quadrants. Subtract our related angle from 180 and then 360 to get our solutions. 2 times cosine of theta is equal to root 3. Well, a little bit of manipulation is needed. Remember, we're trying to get theta. So we have to get down to theta by itself. So we have to divide by 2 to get our related angle of inverse cosine of theta of root 3 on 2 giving us 30. And cosine's positive. So we got the first, fourth quadrants. We got our related angle, 360 minus 330. 330 gives us 330. Cosine of theta is 1 on root 2. Our related angle is 45. Cosine, and it's positive. First and fourth quadrants, we can get our solutions by subtracting the related angle. Tan of theta is root 3 equal to root 3, so our related angle is 60 degrees. And tan, and it's positive. So first and third quadrants are out the 2 we want. And so we get our angle, related angle, and add it to 180 to give 240. Sine this time of root 3, inverse sine of root 3 on 2 gives us 60, so that's our related angle. And sine's negative in the third and fourth, so our related angle adds to 180 in the third quadrant, subtracts from 360 in the fourth quadrant. So there's our two solutions. Again, put them back in, check them every time. One here with a bit more manipulation, because we've got root 2 sine theta minus 1, or we'd add 1 on both sides, divide by root 2, and we're down to one where we've been dealing with. Our related angle is going to be 45. We've got sine, and it's positive, so we're going to be in the first and second quadrant. We're able to get our solutions. So hopefully we're starting to see the pattern that we need to follow, the algorithm we need every time, and why we need that. We need to get our related angle. We need to see what the angle is back to the x-axis, and then we also need to be able to determine what quadrants we're in, because our angle has to be between 0 and 360 degrees. It's important that you check your domain. All these questions had the same domain that was related to, because as we said, technically something like sine of theta is equal to 1 on root 2 has an infinite number of solutions. So you've got to carefully check the problem you're facing, whether it's told to you explicitly, like it did at the problem start here, as saying theta is between 0 and 360, or whether it's implied in the problem, whether it gives you a triangle where it can only be an acute or an obtuse angle, and you've got to be able to deal with that, or you've given some other data that's not explicitly told you, and you've got to infer from the problem what the domain that theta can be in. So in the next few videos, we'll see situations where theta won't be necessarily just between 0 and 360. It might be in other it might be a different domain than that, or where we have to consider other angles as well that we have to play around with. So more of that in the next few videos. But make sure you can do these simple ones really well, because everything we want to do with our trig equations comes down to getting it back to something like the sine theta is equal to 1 on root 2, and then being able to solve from there.